Let's talk about compound interest. So it's better to give a comparative definition between simple interest and compound interest. That will help us to understand much better. Okay. So let's suppose you have two accounts in which one gives you 10% of simple interest and another account gives you compound interest of 10%. And let's suppose you deposit $1,000 in both. First year, 10% of 1,000 is simply 100. Okay, so you'll be earning $100. Okay, so this is your earning, and here also you'll be earning $100. So there is no any difference for the first year. Okay. Now for the second year, your principal would be simply the $1,000. Okay, and again you'll be earning $100 as interest. So your total interest earning would be $100 in the first year, second year also $100, so that gives you $200, right? Now here's the change. Here we have this difference. Okay, in second year of compound interest, the principal will be changed to 1100. You compound this interest to the principal at the end of the first year, or for the beginning of second year, your principal would be 1000 plus 100, that's 1100. The compound interest is calculated over this value, okay, which would be 10% of this one is interest would be simply 110. Now let's see the difference. Okay, now you can see the total earning from compound interest would be simply $210, right? $100 in the first year and $110 in the second year. Now if you go for the third year, then this is quite boring. You don't have any change in here. You'll earn the same amount of interest, and the total earning from this is simply $300. Okay, and now in compound interest, you can see that this 1100 was the initial value for second year, and we need to compound this interest 110 to 1100. So the principal for the third year would be, this one is simply 1210, $1,210. Now you can see the difference, right? Then the interest earned would be $121, right? So the total interest earning until this period is simply 210 plus 121 would be $321. Now you can see the difference, okay, how it is done. So that's the main difference between compound interest and simple interest. In simple interest, your principal remains the same for every year. However, for compound interest, your principal changes according to the number of periods of compounding. So the basic idea here is to compound the interest to the principal and generate more interest afterwards. Okay. Now, caution. What happens if you have credit card debt? Okay. Let's suppose if you have $1,000 credit card debt, okay, then you can see how much you will pay, right? Now, if this thing is done monthly, then see the damage that you will have upon your finances. Okay, so if you see that this thing is done monthly, which usually the credit card company does, and usually the credit card company's APR is nearly 20%, okay, it is at least 16%. So you can see how your personal finance will be affected by that. So that's a caution. But if you spend in, let's say, mutual funds or stocks and compound the dividend growth, then you can see your benefits. So that's a caution. I hope you have learned something about compound interest by now. Now, after learning about the benefits and drawbacks of compound interest, okay, let us go through the formula of compound interest. Compound interest is given by this formula AT, that means total amount over time, Okay, this time may be year, month, quarterly, daily, monthly, or any measurement of time. AT equals to P 1 plus R over N times T. So that's our compound interest formula, where this P is the initial amount, R is the rate of interest in decimals. Okay, don't forget to change this into decimal, and N is the number of compounding in a year, T is time in years, and finally AT is the final amount after T years. Okay. Now here the most important thing is the compounding. Okay, so as I told you earlier that the credit card company usually compounds the interest over a month. Okay, and many business companies, they compound the interest over a quarter period of time. Okay, that's usually where the financial earnings are announced. Okay, and then this compounding per year varies according to what the company does. Okay, so this compounding, number of compounding periods over a year can be annually. That means in a year n equals to 1. Okay, so once a year means n equals to 1, so that's yearly. Semi-annually, so that's twice a year, so n equals to 2. Quarterly, 4 quarter equals to 1 year, so that would be n equals to 4. Monthly, that's n equals to 12, right? There are 12 months in a year. Okay, and similarly it could be for weekly. How many weeks are there in a year? Of course there are 52 weeks, right? Daily, n equals to 365, and so on. Okay, and you can go for smaller denominations also, more denominations also. You can see in the screen that this is page number 472 in the book. An initial investment of $100,000 at 12% interest is compounded weekly. What will be the investment worth in 30 years? Okay, so we'll be using this formula, and let me write down the details. Okay, so the initial amount is P equals to $100,000. Rate is 12% per year, which is simply 0.12. Number of compounding periods. If you read the question, that you'll see that compounded weekly is the phrase that you should look at. Okay, so compounded weekly means n equals to 52, since there are 52 weeks in a year, and time equals to 30 years. So we need to figure out become. Okay, what will be the total amount become after 30 years? So T equals to 30. So essentially we need to figure out the amount in 30 years, which is P equals to 100,000. 1 plus R is 0.12 divided by 52, and to the power n is 52 times 30 years. Okay, T is 30. So here in GeoGebra you plug in all the values, so which is 100,000, okay, times parenthesis start 1 plus 0.12, that's the interest rate, divided by n, that's the total number of compounding periods per year, which is weekly, so that's why we have 52, and go outside, press the right arrow key, and then shift 6, right?
that will give us the exponent sign, okay, and n times t is 52 times, that's asterisk or multiplication, 30, that's 30 years, 30, okay. Click on enter. So we get 3644675.88.
3644675.88. So our projected amount would be $3,644,675. So that would be the final amount after 30 years.